That was probably one of my favorite songs by the late John Lennon called Imagine. And the reason I wanted to play that today was because we're going to talk about imaginary numbers. Okay, these are going to be a little bit different because I know we've never ever heard of imaginary numbers before. So let's try to keep an open mind and away we go. All right, first let's talk about what actually is an imaginary number. We're going to go back to square roots for a little bit with this lesson with imaginary numbers. We just finished our quiz on higher roots like third roots and fourth roots and sixth roots, but for these imaginary numbers we're going to go back to how do we simplify square roots. So let's just take a look at the square root of 36. We know that the square root of 36 happens to be 6. But sometimes a lot of us get confused when we see the square root of negative 25. Most of us want to go right ahead and say it would be negative 5. And I know why you're thinking that, because the square root of 25 is 5, and your thought process is, oh, well, it's negative 25, so why isn't this just negative 5? But actually, if we check it out on a calculator, let's check out the square root. First of all, let's check out the square root of 25. Kind of redundant, but because we already know what this is, but the square root of 25 is 5. And if we happen to try the square root of negative 25, our calculator will tell us, nope, not possible. And I really want you to take a look at what this says. It says non-real answer. So we're not going to get a real number, meaning negative 5 or 0 or a half or any number that you've already been used to using in your mathematical career. The actual answer to this problem is not real. And that's where this idea of an imaginary number comes into play. In order for us to simplify this, we're going to have to use an imaginary number, because a regular number like negative 5, like we're used to, is not the correct answer. So to help us solve these square roots of negative numbers, we're going to use an imaginary number. And this imaginary number we're going to call it I. Okay, not very creative. Imaginary numbers, we're going to use the letter I. And it's specifically equal to the square root of negative 1. This is a huge idea. So I want you to box this in, cloud it in, underline it, draw arrows to it. Okay, this is what an imaginary number is. An imaginary number is I is equal to the square root of negative 1. We're going to use this idea to help us simplify this problem. So even though our calculator tells us we can't do it, we don't get a real answer, we're actually going to be able to simplify it. Our answer would in turn be an imaginary number because it's not real. Okay, so let's think about this. Normally when we think about simplifying square roots, we would break it apart into two different numbers that can multiply together to give us this inside number. Now if we use this idea of a negative 1, I can break apart negative 25 into the square root of negative 1 times the square root of 25. Notice how I took two numbers, negative 1 and 25, then multiplied together to give me this. Now I specifically want to use negative 1 in this case because of this imaginary idea. Since I have a square root of negative 1, I know that that part is equal to I. So I would be able to turn this square root of negative 1 into I, because after all, they're equal to each other. We're letting this be true. We're saying that an imaginary number is equal to the square root of negative 1. So that's how this part simplifies to I. But now that the 25 is positive, notice how it's no longer negative. Now that the 25 is positive, we know the square root of 25 is 5, just like our calculator told us. Okay, right here, the square root of 25 is 5. So this part I can simplify to 5. And I can take I times 5, and just like we would write with variables, normally the letter comes last. Like in 5x, we would say 5i. So we can simplify this square root of negative 25 into 5i. The 5 is telling us that was the simplified answer of 25, but the I is telling us that our original number was negative. Okay, we're not getting a real number, and we're not getting 5 or negative 5, not in this case. We're saying that the number, the square root of 25 was simplified to 5, but since it was negative, we have an I in our answer. Let's try one that's just a little bit more complicated. Hopefully it'll start to make sense the more of these we do. I want to break apart the square root of negative 50 into negative 1 times the square root of 50, just like we did over here. And now the reason, again, that we want to do this is because we know the square root of negative 1 is I. So I can immediately simplify this to I. After all, they mean the same thing. Like we said up here, they're equal to each other. Now this is when we got to kind of remember how we simplify square roots. We want to find a perfect square that can go into 50. And that perfect square is 25, and the other factor is 2. Now, since 25 was a perfect square, just like over here, we simplified 25 to 5, and a lot of us are still having trouble with this. When you simplify a square root, you lose the check mark. Okay, notice how I didn't write a little square root anymore. The moment I simplify it, I lose the check mark. Some of us are still having a little bit of issue with that. Now this square root of 2 is not a perfect square, so it can stay the same. So if I take my imaginary I times this outside 5, I can get 5i, kind of like how we rewrote it over here, but I still have the square root of 2. All right, so let's check this answer out. The 5 and square root of 2 come from simplifying the 50 part. If you were to do the square root of 50 and break it down, okay, you would get the 5 and the square root of 2, just like we did here. But notice how our beginning number was negative. That means we're going to have an I in our answer because this is an imaginary problem. Okay, we are not going to get a real answer to this. It's going to be an imaginary number, and we're going to somehow use this I in our problem. All right, so let's take a look at this imaginary I just a little bit further. We're going to check out and see what happens if we were to take I and raise it to some different powers. Now, we already said that I was equal to the square root of negative 1. Okay, the square root of negative 1 is equal to I. I don't care how you say it, how you write it, but I is equal to negative 1. Let's check out and see what happens if we were to square that. So if this is saying take I and square it, if I is equal to the square root of negative 1, let's square this and see what happens. Now, if you really check this out, notice something that we have here. We have a square root and a power of 2, and we hopefully should know by now that those cancel each other out. A square root and a power of 2 cancel each other out. So actually all I'm left with is the number negative 1 on the inside. So even though a single I is still imaginary, okay, this is not a real number, okay, this is an imaginary number, the moment you square it, it actually becomes a real number. Negative 1 is a real number. So I and I squared are two completely different things. I is imaginary, whereas I squared happens to be real. Okay, you can actually plot this on a number line, on a graph. You can use it in some different math problems. Negative 1 is a real number. Let's check out and see what happens if we take I to the third. So I to the third, we can think about breaking apart into I squared times I. Now this will be helpful because we have 2 here, 1 here. Okay, that gives me 3 total. But I squared, we already said that was negative 1. So I can put negative 1 into the I squared place, and I'm multiplying it by I. Well, negative 1 times I is just negative I. All right, so we're starting to see something happen here. First, I have a single I. The moment I square it, it becomes a negative 1. The moment I cube it, it becomes a negative I. There's some type of pattern happening in here that we're going to try to talk about in a little bit. But last but not least, let's check out and see what happens when we raise it to the fourth. I can break I to the fourth apart into I squared times I squared. Okay, I have 2 over here, 2 over here. That gives me 4 total. We already know I squared is negative 1. And if I multiply that by I squared again, okay, another negative 1. We know negative 1 times negative 1 is a positive 1. All right, so we have this little pattern happening here. I, -1, -I, +1. Okay, we have this kind of alternating I1, some are negative. We have this alternating pattern. Let's check out I to the 5th. Okay, that means we can break it apart maybe into I to the 4th times I. I have 4 here, 1 here. Okay, that gives me 5 total. We know I to the 4th we said was 1, and I'm multiplying that by I. 1 times I just gives me I. And look at that. A single I is obviously I, but then I to the 5th was also I. These are exactly the same thing. We're going to talk about that in a second as well. Let's try I to the 6th. We can break apart that into I to the 5th times I. 5 and 1 give me 6 total. We said I to the 5th was I, and I'm multiplying it by another I. But I times I is I squared, and notice how we already know what that is. I squared over here we said was -1. And take a look at this. These are exactly the same, -1, -1. So maybe we'll do another little arrow here. I squared is exactly the same as I to the 6th. So notice how this pattern starts to happen. We have I, -1, -I, 1. I, -1. We could probably anticipate I to the 7th to be -I if this pattern continues, and then maybe even I to the 8th to be 1 because the pattern is going to continue again. But we would call this a cyclic pattern, because it kind of cycles. It's going to go through these 4 different options. It's going to keep continuing no matter what power you have. So we'll say this is a cyclic pattern. What we can do is use this pattern to help us, because the moment we get to I to the 15th and I to the 34th, these are really big powers. I don't really want to break apart I like I've been doing in these cases. I want to try to use this pattern to help me out. Now, since there are 4 specific options that our answers could be that are going to follow this pattern, we're going to use the number 4 to help us out. All right, so let's take a look at this 15 first. We're going to start with our power of 15, and the cyclic pattern has 4 specific options. So what we're going to do is divide 15 by 4. Now 15 divided by 4 is 3. Okay, so 4 can go into 15 3 times, but we have a remainder of 3. Okay, there's 3 left over. If we were to take 4 times 3, that would give us 12. But to get to 15, we have 3 left over. So what this is telling us is that this I to the 15th is going to go through this cyclic pattern 3 times, a total of 3 times, so 1, 2, 3, but then it has 3 more to go. So if I go 1, 2, 3, and then 3 additional steps, 1, 2, 3, this I to the 15th would be, we would have -I. Okay, so it went through 3 full cycles, okay, 1, 2, 3, but you need to count 3 more, 1, 2, 3, to find the actual value. You can also think about this as I to the 3rd, okay, because our remainder was 3. And notice how I to the 3rd we said was -1. Okay, so that would be our answer in this case. If we try a bigger number, 34, how many times is this I going to go through the pattern? 34 divided by 4. Okay, 4 can go into 34 8 times, and it has 2 left over. So we can think about this as I squared. Okay, because that's how many more we have to go. This I is going to go through this pattern 8 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and then it's going to go an additional 2, 1, 2. And notice how we said I squared. Okay, that was right here. Our value would be -1. All right, so this I, when you keep raising it to these different powers, follows a cyclic pattern. It's going to go through these 4 specific or 4 different options. All right, so let's check out how we can use this imaginary number, this I, to help us solve some problems. If we take a look at the first one, I want to try to figure out what n is. My first step would probably be to divide by -2, because I'm trying to get this n all by itself. So I'd be left with -9 equals n squared. Now, to get rid of a squared, we need to square root both sides. Okay, so square root gets rid of 2, and I'm just left with n. Now, we got to remember that when we take the square root of both sides, remember this is an even root. Even roots need plus and minuses. Okay, we can't forget about those. All right, so notice how we are taking a square root of a negative number. We cannot do that. Okay, we cannot have a negative number inside of a square root. Our calculator would give us a non-real answer. So, I mean, if you want to try it, we could. We can do the square root of negative 9. Notice how our calculator tells us not a real answer, so we're going to have to use an imaginary answer. We're going to have to use an imaginary number to kind of make this make sense. So let's break apart the square root of negative 9 into the negative 1 and 9. Okay, I specifically want to use negative 1 because I know that I is going to come into play. So we can have plus or minus. The square root of negative 1 we said was I, and the square root of 9 is 3. Notice how I lose the check mark when I simplify. Oh, that should be an n. All right, so we could say that our answer, normally we would put the variable or the letter second. We could say our n values are going to be imaginary values, that we can have a positive 3i or a negative 3i. Let's try this one. We want to get x all by itself, so we'll subtract 1 from both sides. X squared equals negative 7. To get rid of a power of 2, we need to square root both sides. Okay, so boom, boom, those are gone. We're left with x. All right, so the square root of negative 7, okay, don't forget plus or minus because we took the square root of both sides. We know we cannot take a square root of a negative number. Okay, it's not a real number, so we're going to have to use imaginary numbers. Let's break apart the square root of negative 7 into negative 1 and 7. We want to do this because we know the square root of negative 1 is I, and the square root of 7, no perfect square really goes into that, so it just stays the square root of 7. But just like over here, we want to kind of put the I last, so we have the square root of 7 and then I. Now just be really careful. This radical bar does not go over the I. Okay, it is only over the 7. So if I see this going all the way over the I, something like that, I'm going to have to mark it wrong or incorrect, okay, because the I is not underneath the radical bar. Okay, notice how it's on the outside over here. Just be careful on how you actually write that. All right, and let's try our last one. Oh, big one. Okay, so let's add 2 to both sides, kind of working from the outside in. And we would get negative 54. Okay, lastly, or next, we can divide by 3. That would give us negative 18. And to get rid of a power of 2, we square root both sides. Boom, boom. All we're left with is y. And remember, we took square root of both sides, so it is plus or minus. All right, so let's break apart the square root of negative 18. We have plus or minus square root of negative 1 and the square root of 18. We know the square root of negative 1 is I. And we can break apart 18. There's a perfect square that goes into it that happens to be 9, and the other factor is 2. All right, so I can have plus or minus. The square root of 9 is 3. I lose the check mark. I have my imaginary number I because, after all, I cannot take the square root of a negative number. I need to show how it's an imaginary answer. And I have the square root of 2 left over. All right, there we go. All right, one more thing we're going to talk about with these imaginary numbers, this letter I, is something called complex numbers. I refer to these, or they're called complex, because they are comprised of 2 different parts. And we say that this first part, notice how there's no I attached to it, like over here on the B. This A we would classify as a real part. Okay, it's a real number, like negative 4 or 5 or a half, or really any number you're used to using. But since this B is attached to the I, this is what's called the imaginary part, okay, because it's attached to that imaginary number I. Now, how I like to kind of remember this is I think about one of my favorite Disney movies, Hercules, and right here is Pegasus, okay, and you might remember this movie or you've heard of Pegasus before. Pegasus is a horse that can fly. Now, obviously, this is an imaginary creature, just like we have imaginary numbers. Okay, this would never ever exist in our world today. But I would consider Pegasus as a complex number. Part of him is real. Okay, and I kind of circled the horse here because, I mean, we have horses. Horses are real. But the imaginary part would be right here, his wing. Okay, because horses don't have wings. So Pegasus, I would consider a complex number because part of him is real and part of him is imaginary. Just like we have this complex number right here. Part of this number is real, whereas the other part is imaginary. Now, I know some of us don't like using letters, so maybe I'll use numbers as an example. We could classify 4 plus 3i as an imaginary number. The number 4 is considered the real part. Okay, it's a number just like we're always used to using. But the 3 is considered the imaginary part because it is the number attached or next to the I. Okay, so this is the imaginary part. What we can do with these complex numbers is actually graph them very similar to how you're already used to graphing ordered pairs on a graph or a plane. But what's a little bit different than the common XY plane is that we have to use something called a complex plane because we are dealing with complex numbers. And instead of X and Y, we use the two different parts. We're going to use the real part as the x-axis and the imaginary part as the y-axis. Okay, so it's a little bit different. If we take a look at letter A, our real part is 4. Okay, so I can go 4 on the real axis somewhere right there. And my imaginary part is a positive 5, so I could go up 5, 1, 2, 3, 4, 5 on the imaginary. So if I go right 4, up 5, I could say right here is where this complex number would show up on the complex plane. Okay, so we can label that A. If we take a look at B, my real part is -2, so I got to go -2 on the real part. My imaginary is -3, so we'll go down -3 on the imaginary axis. So somewhere right here, -2, -3, we would have our point B. Okay, so I think those aren't too bad. It's when we get into C and D where it gets a little complicated. If we take a look at C, we only really have the imaginary part because we only have the number attached to the I. How we want to think about this, though, is if we don't have a real part, we're missing this first number. If we don't have something, it's normally understood to be 0. So my real part, I'm missing it, is 0. But I do have a positive, after all, a positive 3i. Okay, so you can turn just an imaginary number into a complex number by showing that you're missing that real part. So if we were to graph this, I don't really, if I start at the origin, I really don't have to go left or right at all because it's 0, but I do need to go up 3 on the imaginary. So that would be somewhere right here, and we can label that as C. Now lastly, if we take a look at the last one, very similar, okay, to the one we just did. Right now I only have the real part. Okay, notice how there's no I whatsoever, it's just a real number, the number 4. And if I'm missing the imaginary part, again, like up here, we can fill that in with the number 0. Okay, I don't have an imaginary part, all I have is the real part. So I gotta go right 4 on the real axis, 1, 2, 3, 4, somewhere right there. But I don't need to go up or down at all on the imaginary because after all, I'm missing that part. So we'll put a little dot right there and label it D. All right, so let's take a look in how some of these complex solutions might show up when we start to solve some problems. Just like the other ones, we wouldn't try to get n all by itself, so working from the outside of the variable to the inside of the variable, let's get rid of the outside first. We have this little power of 2, and that means we can square root both sides. So those cancel. All we're left with is n minus 1. Now the square root, after all, we took the square root of both sides, so we need a plus or minus, and we would have the square root of -25. Now again, this is our imaginary number coming into play because we have a negative on the inside of the square root. That cannot happen. The square root of a positive 25 happens to be 5, but remember, since it's negative, we need that I. Okay, now if you can think about what I did right there, that's kind of the shortcut way to figure out these imaginary numbers, but you can absolutely break it apart into the square root of -1 and the square root of 25. That's a 25. Notice how the square root of -1 would be I. The square root of 25 would be 5, which is the exact 5i that I got before. So you could think about that little shortcut method again. What would the square root of this be? And throw in the I because it's negative, or you can go through the long way. Now here's where the complex kind of comes into play. I still have an extra step, okay? I'm not really at n by itself just yet, so I need to add 1 to both sides. So now n's all by itself. Now here's the complex. I have a real number right here, okay, a positive 1. So that needs to go first. But notice how I have an imaginary part as well. I have the 5i. So I would have the plus or minus 5i. Now we know that plus or minus means that we have two separate answers. So let's write the two separate complex numbers. Okay, so one of our n's, we would have a 1 plus 5i. Okay, notice how that's a complex number. We have a real part and an imaginary. But the other n value could be 1 minus 5i. Okay, we're using this plus or minus to get our two separate answers. So if you wanted to, you could label this as the real and label this as the imaginary. So those are our complex solutions. Let's try the next one. Again, working from the outside in, we're going to subtract 8 from both sides. So we're left with x plus 3 squared equals, we got -2. We still have some more steps to do. We need to get rid of the power of 2, again, working from the outside in. So square root both sides, boom, boom. We're left with x plus 3. All right, so again, here's a little shortcut. The square root of 2 is not anything that's able to be simplified. So we're going to leave the square root of 2. But since it was negative, that means we have an imaginary number. We're going to use the imaginary I. Okay, there's that little shortcut. Now, just like before, we still have an extra step here. X is not all by itself just yet, so we need to subtract 3 from both sides. All right, so we have our complex solution. Notice how this is a real part. There's no I attached to it, so we'll have -3. Oh, Miss Weitz forgot her plus or minus. Oh, tisk tisk, we took the square root of both sides. We need that plus or minus in there. Here's our real part, and our imaginary would be plus or minus I square root of 2. Now, just like we did over here, let's break it apart into the two separate answers. We can have -3 plus I square root of 2. Okay, that's one possible solution. But we could also have -3 minus I square root of 2. So we have two separate answers, okay, two complex answers in that case. All right, so I want you to take a second and try this one, a little doozy. Okay, see how you do. Really, guys, take a second, pause it, try it, and I'll be back in a little bit so you can check your work. All right, so let's check it out and see how you did. We can work from the outside in, so let's subtract 7 first. Okay, that gave me -8. And hopefully this is where we maybe did not have a lot of trouble. I need to get rid of a 1/3. And to get rid of a fraction, to move it to the other side, we got to multiply by the reciprocal. And the reciprocal of 1/3 is 3. So we got to multiply both sides by 3. That's going to cancel these out. So I'm just left with y plus 2 squared. And then -8 times 3 would give me this -4. So if I continue to work from the outside in to get rid of a squared, we got a square root. Okay, so boom, boom, those are gone. And we can't forget that plus or minus like I accidentally did on the last one. So we're left with plus or minus the square root of -24. If we want to break that down, okay, we can break it apart into the square root of -1, but also 24 can be broken apart into a 4 and a 6. So if I have a square root of -1, okay, that means I need an I. The square root of 4 can simplify to 2. Okay, we lose the check mark. and the square root of 6 cannot be simplified. It stays a 6. Okay, so I kind of did a lot in this step right here. Really take a second and make sure it kind of sinks in. I simplified the square root of -24. But we still have one more step, so that means we're going to have a complex number. Some part's going to be real, some part's going to be imaginary. If we subtract 2 from both sides, I have my real part. Okay, -2 is a real number, so that goes first. And then my imaginary part, the 2i squared root of 6, comes second. But again, we can't forget that plus or minus. So if we break apart what we have right here into our two solutions, we can have -2 plus 2i squared root of 6, or we can have -2 minus 2i squared root of 6. We're just breaking it apart into those two separate plus or minus answers. So I hope you did great. Be ready for next class. We're going to do some practice problems with complex numbers, imaginary numbers, and solving these equations. See ya!